All right, in our third review lesson, we're going to be talking about linear equations, how to solve them, how to find their intercepts, as well as how to graph them. Now, there's going to be two common words that come up a lot when we're kind of working with these expressions. And one is going to be simplify, and the other is solve, and they have two completely different meanings. Now, simplify means you either have to collect like terms, all the terms are on one side of the equal sign, and that you're following BEDMAS while you're doing it. All right, so in our previous lesson, we did a lot of simplifying. We were just for collecting like terms, and then we would stop. All right, that's what simplifying means. All right, it's just you're kind of cleaning up the expression to have it in its simplest form. Now, when we want to solve an equation is when we want to find an exact value for a variable. All right, we want to know what x is or y or z or whatever the letter we chose. We want to know the exact value for that unknown. And this is going to look like when we have problems where numbers and variables are on opposite sides of the equal sign. We have to move everything to one side to solve, and to do that, we use something called reverse BEDMAS. All right, and what I mean by that is you kind of have to do things backwards now. So instead of starting with the brackets, we have to start with addition and subtraction and kind of work our way backwards from there. So how does this work? You would have done this in grade 9. And we have a linear equation here, 2x plus 4 equals 5 minus 3x. And we have to solve for x in this question. So we know we need to go all the way down, and eventually we need an answer. It says x equals something. And the only way we can solve equations is if we move all the numbers to one side, the variables to the other, and then we solve. All right? So we have a 2x and a negative 3x. And then we have a 4 and a 5. So what I'm going to do is I like working with positive numbers. So we pick up the negative 3x, and I want that on the left side of the equation. So it's paired with my 2x. So those are like terms so that I can combine them. At the same time, again, we can do this in 2 steps, but I think it's easier if you do it at 1. I want the numbers together, which means I have to pick up the positive 4 and move it to the right. And when we move things across equal sign, they become the inverse operation, which means, so the 2x will stay, but the negative 3x comes over the equal sign, and now it's going to become a positive 3x. On the right side of our equation, be it the 5 stayed, but now that positive 4 is going to come over to the right side and become a negative 4. Now our like terms are on both sides of the equal sign, so we can combine them. We'll get 5x on the left, and 5 minus 4 is going to be 1. And now we're here. 5x, which means 5 times x equals 1. So I have to move this 5 to the other side, and the opposite or the inverse of multiplying is dividing. So I divide both sides by 5. Again, those 5s will cancel out, and x is going to be 1/5. And again, we don't need decimals. You can leave it as a fraction, and we're done. Same thing on this next one. It's a little bit more difficult, but now we have brackets. And there's multiple ways you can do this. The first way, the way that I would recommend it, is you expand out your brackets first, and then we're going to have to move things around first. Again, I can't move things when they're stuck in those brackets. The only way I can kind of pick things up and move them to the other side is if we eliminate them. So we have to use the distributive property to clean this up a bit first. So again, this is something we went over in lesson 2. Negative 2 times x be negative 2x plus 12. And I'm actually going to leave that negative here for a reason. That's going to be equal to negative 4x plus 20. I just want to pause there. If you look at how I've written this equation, notice how I've started it with the equal sign, and then I have another equal sign here. Right, this is a habit that a lot of you are going to kind of get into, is just writing equals no matter what when you start a new equation. But we only want one equal sign per line, not a big deal. So try not to write this one at the front, because we only want that one equal sign in our equation per line. All right, if you really want to write something, you can write an arrow, but we don't want to write 2 equal signs, all right, on the same line. So now this just looks like what we had in our first example, and we'll go through and solve. I'll pick up, I'm going to move the negative 4x to the left, and I'll pick the positive 12 then, move that to the right. So when you go over the equal sign, it does the inverse. So we'll have negative 2x plus 4x is equal to 20 minus 12. Right, and simplifying this, we get 2x is equal to 8. And again, to move this 2 to the other side, we do the opposite of multiplying, just dividing, and then we get an answer of 4. Now, if you really aren't sure if you're getting the right answer, you can always plug it back into the value of x and see if both equations or both sides of the equation equal the same thing. Right, we know how to check our answers if we need to. And here's the last one. All right, negative 2x divided by 3 equals 4 divided by 7. So how do we solve this one? And a lot of people might just say cross multiplying, but I wanted to make sure you know why we have to do that. So we don't like working with fractions. We really don't like working with fractions. So we want to eliminate our fractions as soon as we can. And the way we do that is I'm saying on the left side, we're dividing by 3. So if I want to not do that, if I move the 3 to the other side, the opposite of dividing by 3 is multiplying by 3. And same with the 7. If I want to get rid of this fraction, the opposite of dividing by 7 would be multiplying by 7. All right, and that's where the topic of of cross multiplying, that's where it kind of comes from. It's because you have to do the opposite of dividing, which means you multiply on the other side. And what this ends up being, if you simplify it, well, 7 times 2x, and I'll keep the negative 2x, will be negative 14x. And 4 times 3 is going to be 12. And again, we have it nicely simplified here. And now I just need to solve for x, which means we have to divide by negative 14. So x is equal to negative 12 over 14. Again, it doesn't matter where you put the negative. It just means that whole term is negative. It's not necessarily the numerator is negative or the denominator is negative, right? The term is negative. And if you wrote 12 over 14 as your answer, it'd be right, but you could make it simplified. Right? We want to have our fractions in lowest terms. And it was 12 and 14 can both be divided by 2. We can make this a little nicer. It says negative 6 over 7. Right, so those are solving skills that you should have coming into this year. Now, graphing using intercepts. Right, not everyone maybe saw this last year, but I want to make sure we know how to graph using our x and y intercepts because it is very, very handy, especially when our graphs are written in standard form like this. So it says here the x-intercept is where the graph crosses the x-axis. All right. And the y-intercept is where the graph crosses the y-axis. Now, if I draw a set of axes on this chart, now you have to bear with me. Normally, I would use a ruler, but rulers don't work well on the iPad for some reason. Every time I try to use it, it gets messed up, and the screen goes all over the place. So, if this is my y-axis, and there's my x. All right. Those are drawn in. The y-intercept is where the graph runs through this line. And the x-intercept is where the graph hits on this line. Now, when we put our points in, we know that any point that hits the x-intercept, so any of these points, let's say, the y value on that axis will always be 0, right? The y-coordinate is always 0 because you're right along the x-axis. And on the opposite one, for the y-axis, your x value will always be 0. And why this is useful is because you already know what one of the coordinate points is. If you plug it into the equation, it will give you the corresponding value for the other variable. So how does this work? If I want to find the x and y coordinates of this expression, how do I do that? All right. Well, let's see. If I want to start with the x-intercept, that's where y is equal to 0. Where the graph hits when y is 0. So all we're going to do is we're going to take our equation, 2x plus 4y, and instead of writing 4y, we're going to replace the value of y with 0. All right, and now let's see. We actually have to solve what is x. So we'll get 2x. Well, 4 times 0 is nothing. That just disappears. And we get this. And now let's solve for x. Well, I'll take that negative 15. We want all the numbers on the same side. We'll move it to the right. Which will be 2x is equal to 1 plus 15, or just 16. And then we'll divide both sides by 2 and get x is equal to 8. So our x-intercept here, the x-intercept is equal to the point 8, 0. That's where our x-intercept is. So we can put that point on our graph. And just for the purpose of this, I'll make every x-coordinate 2. So there's 8, 0 would be right here. All right, and then we'll do the same thing for our y-intercept. Except to find the y-intercept, that's when x is equal to 0. Where does our graph hit that y-axis? We'll take that exact same equation, but now for x, we're going to replace the x value with 0. So we're left with 4y minus 15 equals 1. The negative 15 goes to the other side and becomes a positive 15. And we're left with 4y is equal to 16. And now, same thing, we'll divide out by 4 and get y equals 4. All right. So therefore, our y-intercept is equal to 0, 4. All right, well, 0, 4 is going to be, again, if I make it the same, right here. And now that I have those 2 points, I can draw in my straight line by just connecting the dots. And there we go. There is our equation of our graph of our line. There we go, done. Now the next 2 are ones that people always get stuck on, but I think they're way nicer than what we just did. So we have to draw this line, y equals 3, and we'll do it in purple. And all we're doing is you have to draw a line that no matter what, the y value will always be 3. And how I think about this, and the way I've drawn it, is y being 3 is right here, right in between 2 and 4. Now I have to draw a line where y, no matter where I go, stays 3 the entire time. So this ends up being just a straight horizontal line. Again, remember, no matter where you go on this line, oh, that's a little bit crooked. Let's see if this is going to work for me here. Oh, nope. Again, this is me trying to use ruler. See if it goes. There we go. It's close enough. So you see, no matter where you go on that line, the y value, or the height of this line, never changes. It's always 3. On the flip side, if I ask you to draw a line where it says x equals something, all right, and let's use blue. Now we have to draw a line where the value of x stays 5. So no matter where, which x is 5 is right here, no matter where I draw this line, the x coordinate on every point is 5. right, so there's my line. And we can see anywhere on this line, the y value as I go down is changing, but the x value stays the same. It is always at 5. And how I think about it is if you draw the line x equals 5, it would go right through the value of 5 on the x-axis. In this one, for y equals 3, we drew a line that went right through the y value of 3. And there we get our vertical, horizontal, and diagonal lines done. Now, last thing, and before you guys have got all your review done and we'll start our unit 1, is we have to know from a table if something is a linear graph, a quadratic graph, or it's something completely different. So since we haven't talked too much about quadratics, we're just going to call them linear and non-linear. Linear being a straight line, non-linear obviously not straight. And hopefully you did something called first differences last year. And what this meant is by looking at a table, you can tell, depending on the pattern, if it is a linear function or not. And if it's linear, the first differences are the same. And what I mean by first differences is how much you go from this first point to the next point, how much did you go up or down every time. So I see here from 4 to 7, we went up 3, and then from 7 to 10, we went up 3. We saw our differences here are the same, so therefore, this is a linear relation. On the second example, though, all right, if I'm looking closely, you have to be close. From -7, or 5 to -7, we're going down 2. But then from 7 to -10, we're going down 3. You can see that those values are not the same. Therefore, it is non-linear. It is something else. Now, there's a lot of functions that we're going to look at this year that you haven't seen before. We're going to look at quadratic, some exponential. You might even get into some sinusoidal functions. Lots of things we're going to look at. So we're going to kind of see, and we don't even need the graph. We can just from the table be able to figure out what kind of relation we're working with, which is very helpful in kind of deciphering data from a table. Anyways, that's all the skills that I think you guys need to have before we start. If you have any questions, please let me know, and I will be in the Google Meet room just in case.